In this problem, we want to factor out the greatest common factor from x to the 9th y to the 6th plus x cubed y to the 5th minus x to the 4th y cubed plus x cubed y cubed. Okay, well, remember the greatest common factor, the GCF, gets the smallest exponent. Smallest exponent. Okay, so let's find the GCF first. All right, so we have y, let's look at x to the 9th, x to the 3rd, x to the 4th, and x to the 3rd again. The smallest of all of those, x to the 3rd. Let's go back and look at the y's. Y to the 6th, 5th, 3rd, and 3rd. So again, y to the 3rd. There's our GCF. It's half the battle right there. Okay, now let's factor out the GCF. Okay, so when we factor it out, x to the 3rd, y to the 3rd, it comes out to the front. Well, that's clear enough, but then what's left? So factoring out means dividing. Factor out means that we're dividing. Because when we factor something out, we divide each term by whatever we're factoring out. But when we're dealing with exponents, dividing means subtracting exponents. So I'll say subtract exponents. Okay, so factor out means we subtract the exponents. So here we have x to the 9 minus 3. So x to the 9 minus 3, which is x to the 6th, y to the 6 minus 3, y cubed. All right, plus x to the 3 minus 3, well, that's just x to the 0, so there's no x's left. Y to the 5 minus 3, which is y squared. Okay, minus, right, x to the 4 minus 3, x to the 1, which we just write as x, and then y to the 3 minus 3. Remember, y to the 0 is actually 1, so that's just going to leave us with x. All right, plus, look at this, x to the 3 and y to the 3. You can think of that, if we factor the whole thing out to the front, there's nothing left. But it's not nothing. There's always a 1 here for a placeholder. And a good way to think about that is if we were to multiply this back through, we'd want to end up with x cubed, y cubed back in this place. So we need a 1 here to ensure that it's still there if we were to multiply back through. Okay, or you can think of it as subtracting exponents. X to the 3 minus 3 is x to the 0. Y to the 3 minus 3, y to the 0 is still 1 times 1, which is 1. However you want to think of it, both ways give you 1 here. And voila, there is our factored form. We have factored out the GCF. Let's try another one. Again, we want to factor out the GCF, but now we have fractions. So let's see, we have 2/5 y to the 7th minus 4/5 y to the 5th plus 3/5 y squared minus 2/5 y. Yikes! But do not fear, this isn't as bad as it looks. Let's deal with this one at a time. Kind of, I guess, one thing at a time. Look, we can factor out, look at all these denominators, they're all the same. 5, 5, 5, 5. So, you know what? Let's factor out a 1/5 here, first off, and just get that out to the front and see what we have left. That leaves us with 2y to the 7th minus 4y to the 5th plus 3y squared minus 2y. Okay, it already looks better. Just getting that 1/5 out of there. All right, now let's look at the coefficients. Okay, so we have 2, 4, 3, and 2. The only number that divides all of those, 2, 4, 3, and 2, is 1. So there's no number for the numerators that we need to take out as part of the GCF. All right, so that solves that bit of it. Okay, let's look at these variables. Just the variables, we have y to the 7th, y to the 5th, y squared, and y. Remember, the GCF always gets the smallest exponent. In that case, it is y to the 1. Okay, so we're going to pull out a y to the 1 here. So our GCF then is 1/5 y, which I'll write as y over 5. Okay, and when we factor out a y, really we're subtracting exponents, because factoring out is actually dividing, and when you divide exponents you subtract. So that's going to be 2 to the y to the 7 minus 1, since we factored out a y to the 1. There's a little hidden 1 hanging out there. So y to the 7 minus 1, which is y to the 6th. Okay, minus 4 y to the 5 minus 1, y to the 4th, plus 3 y to the 2 minus 1, y to the 1, which I'll just leave as y, minus 2, well, here the whole y to the 1 comes out, or you can think of this as y to the 1 minus 1, y to the 0. That just leaves us with 2 there, and there you have the factored form.